Okay, I'm gonna go ahead and get started. People are gonna, keep on rolling in. Um, but yeah, welcome everybody to the um first Big Think meeting of the semester. We're really excited to have you guys here, and yeah, let's just jump right into it. If anytime I have audio issues or I'm barely audible, please speak up and let me know so I can try to uh amend that. But yeah, so this is the first meeting. We're going to be doing a very quick intro to ML, very, very basic one. We'll be diving much more into that in later meetings. And then we're going to be doing a bit of an introduction to Python. I'm going to be speaking until like 4:30 so, and then Philip is going to pick it up from there. But yeah, let's just get started then. Everything good on your end, Philip?
I mean, yeah. How do you expect me to hop in though? Because you're the one hosting the meeting and screen sharing. So,
All right, can you switch ownership?
okay. Well, sure, makes sense, I suppose.
Yes. All right.
Okay.
We start to Cynthia Washington. Okay, so it looks like they changed.
Could whoever's mic is on mute, could you please mute it? Thank you. Yeah, so this is what we're gonna be doing today. Yeah, so first off, let me just introduce myself. My name is Rod. I'm currently a senior, it's my last semester at UMD, major in comp sci, the machine learning concentration at UMD. I'm also a statistics minor. On my free time, I do play guitar. I'm in a band here. You'll be hearing from me about that a lot. Not important now. But yeah, just as an overview of what the club actually is, since a lot of you here are new. So we learn about data science and machine learning concepts to eventually code up a final project in Python that solves the problem that utilizes machine learning. So you guys are going to be learning through hands-on coding exercises, and me and Philip are going to be heading most of the meetings here, and both of us have our respective experience in the industry when it comes to machine learning as well as academic research. But the most important thing to realize is that we assume zero prior knowledge about data science or machine learning beforehand. We're going to be starting here completely from scratch. The only prerequisite, I guess, is to have some grasp on any programming language there is. Just I guess CBC 131 equivalent, if I want to say something for tuition classes. But yeah, this is pretty much saying the same thing that I said in the previous slide. So I'll just skip that. Examples of past projects we've done. So in the past, we've used neural networks, which is a type of machine learning model to detect whether a given human cell was infected with malaria or not. In another semester, we used a logistic regression model to predict whether a given employee would quit their job. I believe that was a data set from IBM. Let's see here. Semester plan. So right now the semester plan is very tentative. It's subject to change, but we will be sharing this document very soon with y'all. It has basically each day what we're going to be going through and the exercise and the slides for each day as well. Kind of like syllabus, I guess, if you want to say. But yeah, we're still working out the final kinks and details. It should look something similar to this though. Spoilers. But yeah, we'll be sharing this document very soon with y'all as far as the semester plan is concerned. Let's see here. Yeah, so let's get right into it. So what is machine learning? We keep on hearing this buzzword everywhere, but like, what does it actually mean? So in a sense, machine learning is essentially programming computers to learn from experience without being explicitly programmed. So essentially, I guess the most popular example that everyone is talking about now is ChatGPT. Chat GPT, right? Or GPT-3. That is essentially giving a program thousands and hundreds of thousands of rows of data of text and telling the program to learn from experience how to. I don't know the exact details of it. Maybe Philip can explain better, but I believe the core concept is to make it to train it to be able to talk like a human or to respond to human text or answer queries, and it's gotten pretty good at that. And the main essence behind that is that no one has explicitly programmed Chat GPT what to respond for certain questions. It's learned that stuff by its own, just by observing data, observing patterns, etc. A big question people usually have is like, what is the difference between ML and AI? And the definition is kind of vague, but essentially we think of machine learning as being inside artificial intelligence. Artificial intelligence is more of a broad term. It's just programming with the ability to learn and reason like humans. Machine learning models, as you'll see, is a little more specific, a little bit more specific than that. But yeah, did you want to chime in on anything, Philip? What I just said?
Nope.
Alrighty then, I'll assume you thought I did a good job. But yeah, so that's that. Again, we'll be going into much more detail about this in further meetings. But yeah, so this is another way to answer the same question, I guess. But there's a good quote, and essentially, machine learning is just using data to answer questions. So right here we have a screenshot of 5 rows of the Titanic dataset. And what the Titanic dataset is, it is a dataset. It's a collection of information of passengers on the Titanic and characteristics that they had, such as their name, their sex, their age, where they were located on the ship before it crashed, etc., etc. And essentially, the question that we want the computer to answer here is, given the characteristics of a passenger, let's say, for example, Mr. Owen Harris, predict whether or not that passenger passed away, or rather predict whether that passenger survived the Titanic crash or not. So on a very, very high level, you may start to wonder, the machine may start to pick up on patterns in the data, such as, well, if they were in a certain class that was, closer to lifeboats, I suppose, or that was not as affected by the crash, they would tend to have a higher number of people survive. So perhaps the machine learning model will learn that certain passengers in a certain section of the boats would probably have a higher chance of surviving. So they would most likely survive. Or they could observe a pattern where the younger of folks had a higher chance of surviving. I'm just throwing out examples up there. But essentially, what I'm trying to say here is that the machine learning model picks up on patterns that exist in the data. And based on that, it learns to answer these questions that we throw at it. But yeah, that is another way to look at it. This is like a high-level overview of the machine learning process. So as I said, it's using data to answer questions. So at the very beginning, we call the data that we trained the model on training data, appropriately so. And what happens in a training stage is that the machine will take the data, make initial predictions. It will compare its predictions to the actual truth. Like, for example, if we go back here, if, for example, the computer guessed that Mr. Owen Harris survived, it would compare its prediction to the actual result. Now, in this case, it looks like I'm pretty sure survive 0 corresponds to did survive. So if it predicted that he didn't survive and the actual truth is that it did survive, that will be an error on its part. So that's where we have this check cost, like how far away was your prediction from the truth? And then, try to optimize on that and try to get better next time. And essentially, this training stage, you can think of that one example, but multiply it across millions of times, millions of trials and errors until it keeps on getting better and better and better. And then, essentially, once you have a trained model that was learned from experience and learned from its mistakes, you finally give it to test data. Essentially, data you haven't exposed the model to yet to see if it's accurate in its predictions. And yeah, that's again, it's very high level overview for now. Much more details come later. But yeah, these are just some applications, machine learning in the real world. Nothing that pretty sure if you don't already know it, right? But as you can see, machine learning is very applicable in the real world. Everything from email spam filtering, from online fraud detection. There's a lot of them there. So definitely having this knowledge is a great tool. Yeah, so with that, we're going to move on to Python. Did anyone have any questions about what I just went through so far? All right, I will take that as a no. So what is the reason we're really doing Python machine learning anyways? Well, it's simple. As you may have heard, the syntax is not very heavy, and easy syntax allows to focus on the actual data analysis and the machine learning model. There's a lot of libraries. There's a lot of support for libraries and machine learning, and essentially libraries will make it so that we don't have to program machine learning models from scratch. They're kind of like pre-built for us in a sense, and you'll see what that means. Let's go into coding examples and popularity, because Python is very, very popular. So there's a lot of community support if you have any questions. But yeah, I'm essentially gonna go off the assumption that y'all know a C style language like Java coming into this. It's okay if you don't, but I'm just gonna be using Java as a reference point to teach Python. So yeah, the first thing I guess is that in Python there is no main function that you have to put stuff in. Whenever you write Python code, it executes sequentially, so from top to bottom. So you don't have to wrap out your code into this main function. You can just code whatever you want. It will read it sequentially. Do I have an example? Oh yeah. So one thing you have to keep in mind, because it does execute from top to bottom, is that you have to be careful about where you define your variables and stuff. You have to make it do it in a way that makes sense. So if I do this, if I define a number variable, I call it X, and I print it out. Give it some time here. Not sure why it's so slow. Oh, there we go. Apologies for the delay. Yeah, so it just took our variable, printed it out. Now, if we were to define this below the print statement, like if we defined a variable after we called it, that would be no point. Well, I think 1 second. Yeah, there we go. So if we define a variable before we call it, it's going to say why it's not defined, because again, it goes from top to bottom execution. So just remember that order is important when you're coding Python. Okay, next, variable definitions. I guess kind of showed this to you already, but essentially Python, you don't have to specify types like you would in Java. So in Java here, you have to specify that I want a string that's called phrase. So you go string phrase equals whatever string is, or you want a number, so you specify you want an integer, so you call int, meaning life, yada yada yada. Python, all you have to do is give a variable name equals and then the value. So if I want a string that's called green day, I just have to give the variable name, in this case it's band, equals the value of the string, green day in quotes. And I guess I'll just demonstrate this again because why not? So I want a string called name, just name Sam. That's completely valid. I want a number called, a number of value 45. That's totally valid too. But yeah, you get the point. All of this is valid Python. It will print out without any fuss here. Yep. Do not need to specify the type. That is the main takeaway from that. One quick miscellaneous thing I want to bring up here is what booleans look like. So booleans, I believe in Java, booleans look what true and false kind of look like these with lowercase letters. Here, it's gonna be the same thing, except they're gonna be starting with uppercase letters. See, true and false. And I believe true and false are considered objects in Python. So that is also thing to take into consideration. But yeah, that's just a little miscellaneous thing I wanted to point out there. Any questions so far? No? All right. Perfect.
My mom
All right. Now that we've done variables, let's go over conditionals. So conditionals kind of do function the same way you would see in Java, except there are changes. So instead of curly braces, we use colons to demark the start of the if and else clauses, English. And because we are foregoing the use of curly braces, we need to indent any code that is under the clause. That is very important. And I will show you exactly what happens when we don't indent the code that is underneath the if and else clauses. Jesus. Yeah, so over here, I made a very simple if else thingy right here. So we define a variable called age, and it checks the value of age, and it prints a message depending on what the value of age is. So as you can see here, to demark the start of each clause, I use colon, and then I indent all the code that comes under that clause. I can, do another print statement here. But watch what happens. Well, let me just run this first and see what happens. Yeah, so it just prints out this last one here because it is below the value of 10 and 20. However, if I were to remove this indentation, let's see what happens. You get this thing called an indentation here. So it is very important that you indent all of the code below your if and else clause. Otherwise, it will not work. Another small difference you may have noticed is that instead of else if, you have this keyword called elif. It's pretty much literally exact same thing as else if. It's just called elif in Python for some reason. But yeah, other than that, that's pretty similar to Java as well. Cool. Any questions about that? Questions at all? Alrighty.
Wow.
Ooh. Okay, lists. So this is a pretty full circle moment, but better you know here, Nelson, I actually took this 131 class back in like fall 2019, so I'm a bit of a dinosaur. So but I remember him saying one day in class that array lists are like arrays on steroids in reference to Java. Well, here I am saying that lists in Python are like array lists are on steroids, and you'll see what I mean by that in minutes. But essentially, the way you define a list is that you give a variable name equals, and then square brackets, and then you list whatever items you want inside the arrays. And in order to access a particular element of the list, it's pretty similar to Java. You just give variable name of the list, and then you put the index you want in square brackets, and it will return an element. In this case, I'm actually defining what should be in the first line. rather than accessing something. So it's, in this case, I'm saying that bulldog should be the first element of the list. But that being said, let's do a little bit of an example here. So can I get some people here to shout out the name of some animals to put in this animal list?
I'm still a little bad. But I swear I will bring
Any
you,
animal in the animal kingdom will do. You can either unmute yourself or type in a chat.
the big chocolate ones.
No.
All right, getting some responses here. A rabbit. Okay, so in order to do this, I would surround the thing I want in the double quotes because it's a string. I'll put the thing here, rabbit, then a comma to separate the element, and I'll put a line here, another comma to separate zebra. Oh, y'all are getting creative here. Comma, separate.
Wow, I'm getting.
I think that'll be good for now. As you can see here, I surrounded elements in square brackets, and now we have list. So if I wanted to access the last element of this list, does anyone know the well, I kind of already gave it away, but does anyone know the code I would do if I wanted to access the last element of this animals list? Put in the chat, or you can say it. And just to repeat, does anyone know the code I would type here to access the last element of this list, the animals list? It's pretty similar to what we have in the slides over here. Yep, Tyler got it right. Good job, Tyler. So we just name the list, put the square brackets, and put the index we want. And I'll just print it out so everyone can see what happens. And cockatoo, brilliant. Oh, I didn't see the other responses there too, but Jalal and Aaron also got it. So yeah, great job, guys. Alternatively, just a little bit of miscellaneous knowledge, but you can also access the last element of a list. You can also do -1. It'll print out the same result. Just a little neat little Python trick. And you can do -2, it'll be like the second last element. So yeah, just like, you know, Python has a lot of neat tricks and kinks here and there. Aside. Okay, any questions? Any questions at all? Please do stop me if you have a question about this. All right. So functions. So the way that you define a function is pretty simple. You use the keyword def, which stands for define. Then you have a variable name. You have the name of the function. In this case, it's add. Then in parentheses, you name out the parameters here. Now notice again here that you don't specify the type of the parameters. You just give the name of them. It's pretty simple. And then similar to what we had in conditionals, we start the function clause with a colon. And then also similar to if else clauses, we indent all the code we want in the function to demarcate what we want inside the function. And then return keyword is pretty much the same. We return whatever we want. We don't necessarily have to return, but that is the option to return. Yeah, so let's just go back to the example.
Yeah, good luck. If you get bad, don't blame us. Blame Starbucks. Blame the creator.
So here, it's a pretty similar example to what we had there. So define the keyword, the name of the function, the parameters that we have, whatever code we want inside the function, and return what the value we want if we're returning something. In order to call the function, we give the name of the function, put the parentheses and pass in the parameters, and it will do just as advertised. Give us -3. Fun little exercise for you. Think of how to define a function that multiplies two numbers. It is pretty simple, but I'll let you do that on your own time. Let's see here. Okay.
Yeah, it's
Cool.
yeah, yeah. I forgot to hang up.
All right. The last little exercise, sorry, not exercise, the last mini topic I have here, Python, are loops. So loops are, I would say they look much neater in Python than Java. So in Java, you had to declare your initialization variable to give the condition when to stop the loop, when, I is less than 3 in this case, then increment the value of I each loop. And then you have your code within the loop. In Python, all you have to do really, well, there's multiple ways to define loops, so I'll give you one way. Python, all you have to do is define your initialization variable I here. It could be literally any other name, it doesn't have to be I. So for I in range, and then the number of times you want the loop to run for. And then you, again, very similar to functions and else clauses, put a colon here, indent the code you want under the for loop, and it will do the rest for you.
Well, that is true. But you didn't say you wanted it.
Let's see here. Okay. So for the example here, I'm going to use our animals list that we had back there. So here, I know prior the animals list is length 4, so I'm just gonna put 4 here in the range to make sure that this loop operates for 4 times, and it's gonna print out each element in the list here. I'm just gonna comment this out, and it should, there we go. It printed out the element, each element of the list, because we iterated through the array list using our I variable. Now, if I were to just print out the I variable, you'll see that it increments at each one. See, it goes from 0 to 3, because we zero index in computer science. For whatever reason.
No, it's not.
Okay.
It's not.
So at this point, I'm going to hand it
Yes.
over to Philip, who I have to give host permissions to. And he is going to guide you guys through the exercise at the end of this meeting scratch board, which I'll actually paste in the chat, just for reference. Does that sound good to you, Philip?
Yeah, sure. I'll just start screen sharing one sec.
Okay, I will stop screen sharing then.
Oh, I missed that one.
Well, you already did. Don't worry.
Oh, I did? Damn. Okay, cool.
Big brain time, Samrat.
All right, it's been real, guys. I'll see you next meeting.